Today we'll look at inequalities of this form. So whenever you see an inequality of this form, first you don't cross multiply as if it was an equal sign here, or else you might get something absurd like 0 equal to 2, or if you cross multiply you will find the solution, but you might not find all of the solution on the real line. First, when we see an inequality like this, we'll have to simplify it. We'll get this form. This implies 2x minus 1 on x plus 2. This one comes this way, plus 1 to be less than 0. So when we simplify this, we get 2x minus 1 plus x plus 2. That is by finding the LCM all over x plus 2 to be less than 0. And when you simplify this, you get 3x plus 1 all over x plus 2 to be less than 0. So we can call all of this f of x. We can call all of this f of x. In other words, we have to find the range of value for which f of x is less than 0. So firstly, we need the zeros and the critical values. So for zeros, the zeros are the values that will render f of x 0 and will occur when the numerator is 0. Zeros will occur when 3x plus 1 is equal to 0. Equals to 0. From here implies our x is negative 1/3. Then the critical values are values that will render f of x to be undefined and will occur when x plus 2 equals to 0. Implies that our x should be negative 2. So we'll represent this on the real line with respect to these points, to the 0 and the critical value, that is x bar. We'll present it on the real line with respect to, let me start with the smallest, negative 2, negative 1/3. So if we have our real line like this, something of this form, yeah. So on the real line, let me represent 0 first. We have 0, negative 2 is somewhere here, negative 1/3 is somewhere here. So this is a negative axis, positive axis. So we have to test for values between less than negative 2. Test the sign of f of x with values less than negative 2, and values between negative 2 and negative 1/3, and values greater than negative 1/3. So if you take a value less than negative 2, take it, be it negative 3, negative 4, any value. By the time you substitute it here, the sign of f of x will be positive. We'll get a positive value. When you substitute, let's take negative 3, if you substitute here, you get a negative value on a negative value, which is positive. So which means any other value below negative 2 render it f of x positive. Okay, we'll take a value between negative 2 and negative 1/3. Let me say negative 1. By the time we substitute here, we'll get a positive value, which means the sign of f of x is, we'll get a negative value, which means any other value between negative 2 and negative 1/3 is, will render f of x to be negative. So now we'll take a value greater than negative 1/3. Same thing, we can take 0, yeah, a value greater than negative 1/3 to get 0. By the time we substitute 0 here, we'll get 0 plus 1 on 0 plus 2, which is half, and half is positive, which means any other value above 1/3 will render f of x to be positive. So as such, we have occupied the real line. So our general solution will be equal to, since that is, we'll find the range of value for which f of x is less than 0. In other words, the range of value for which f of x is negative. So we'll come on our real line. The part where we got negative is our solution, which means our x will lie between negative 2 and negative 1/3 for this function to be true. So negative 2 less than x less than negative 1/3. So that's our general solution. Thanks for watching.